Good evening, everyone. My name is Sam Nasser, and this is the Cleveland C# VB.NET user group. A little bit about the user group. We meet every month. The meetings are free of charge and open to the public. Typically, we meet every fourth Thursday, and we cover any and all topics related to .NET. You can find meeting information for both past as well as future meetings over on meetup.com with the link listed below. We'd like to welcome a variety of attendees that are coming from all over, but specifically those joining us from the Lansing area and the glug.net user group. Thank you for joining us. And we'd also like to give a big thank you to our sponsors, Tech Systems, Inedo, PostSharp, and DevExpress for sponsoring the prizes. And lastly, we'd like to give a big thank you to NIS Technologies for the web hosting. We have a special offer from Manning.com. If you utilize the discount code MTPCLEC21! You can save 35% on a selection of books that are listed at the URL there. And the URL, as well as all the other links pertaining to the YouTube and the eval form, will be posted in chat in just a few minutes. So some general announcements. Please keep in mind participation is always encouraged. And like I always say, the only stupid question is the one not being asked. So feel free to jump in at any point in time with comments or questions. However, when not speaking, kindly ask you to mute your mics to avoid any background noise. So typically the meetings, they're fairly casual, but at the same time, we like to keep them organized. This way it gives a time for the speakers to go through the demos and the slides. The presentation is being recorded and will be posted on the YouTube channel, and the link will be made available in the chat window as well. They will be posted on the Meetup site under the comment section, so you can grab them from there. So moving on to tonight's feature presentation, we have the privilege of having Mads Torgerson and Dustin Campbell, both from Microsoft on the development team for C#. Mads is the lead designer of the C# programming language, and he's a program manager at Microsoft. Dustin is the principal software engineer on the .NET Developer Experience team. They both work on the C# language. Dustin is also focusing on the .NET tooling, trying to make it a great experience and helping design the next version of C# as part of the design team. His prior work includes working with Roslyn, as well as developing the next generation of C# and VB IDE experiences. And so without further ado, I will turn it over to Mads and Dustin.
Awesome. Well, thanks for the nice intro. It's a pleasure to be back. I was here, how long ago, Sam?
About a year ago, roughly.
It was you probably said C# 9 the last time in the title.
Yep.
And, Dustin and I find that we have a lot of fun giving these talks together. So
totally.
And he doesn't get out much, so I let him tag along.
It's lonely here, yeah. It's very lonely in here.
Well, glad to have you both.
It's great to be here. So I wanted to start out by saying that the talk title is C# 10, I guess, which is the version of C# that we just shipped in November, and that's where we sort of brought some demos and stuff that we prepared a little bit, but we really intend for these 2 hours to be interactive and a conversation, and anything related to C#, technical or otherwise, is fair game. And any amount of detail or digging in is best done while we're on the topic. So please, please, please chime in along the way, ask questions about what we're showing. We can always dig in further, try things out on screen, and we don't have material to speak for 2 hours nonstop.
Not even a little bit, right? Yeah.
Don't take us in some direction. We just run out of steam. So we're happy to talk about anything. What's on the docket next for C#? How do we approach designing? How do we think about C# and so on? All these kinds of things. So please start thinking about what are some good things. What are some things you would like to know, and we can take it in any direction you like. But just to get you all warmed up, we'll just start in a corner of C#10 and start explaining things. And I don't see, it's a while since I've been in GoToMeeting. I don't think there's a raise hand feature here. So I think I've got the chat open. If you have questions or comments, feel free to either do them in chat or just unmute yourself and ask. We really don't mind being interrupted along the way. On the contrary, it makes it all more fun. So so please come online and chime in. And
there's few enough here that we can have a more discussion and a little more interaction. That'd be great.
Right. So with that, and I should say one more thing, which is that roughly halfway through, we're going to uphold a C# design meeting tradition. The C# design meetings are also 2 hours long, and we have in the middle, we have what we call a bio break, so that everyone can go and take care of business at the same time. And we will have a 5-minute break in the middle, just so you know, so you don't have to sneak out. We can't see it anyway because you all turned off your cameras, but just know that there will be a break in the middle where you won't miss anything.
Yeah, don't leave your mics on or anything though. That's the key
there are some tricks to it. Okay, Dustin. So while I was talking here, you brought up some source code.
Yeah, I'm gonna change the solution here though, because it's got kind of a weird. There we go. This project title here. Okay, that's better.
All right.
Just quickly, yeah, we've got this is some features we put together for C#10. Now I don't know how many people have been playing with C#9, but one of the big features we added was records to C#9. It was something that we've been trying to get in for seems like decades, but no, it has been a couple of releases of C#, and so we've as we've introduced these features and as we've gone over the last couple of releases of C#, we've tended to kind of iterate on existing features and continue to refine them with each release of C#, and records are kind of no different, right? So so Matt, I think the very first feature we should show is the fact that we added a keyword for records. If you recall, we made it so because records are classes, right?
Yeah, we should maybe just do a super quick recap of what records are again for those that, I mean, we can't do show of hands, but so records in C#9 are really a kind of classes. So you use the record keyword instead of the class keyword. And then what happens is that we generate some extra things into your class, the class person in this case here, that make it essentially value-based, that make it behave more like a value and less like a mutable stateful object. For instance, the equality is value-based. It'll compare all the fields instead of just the references of the object, and a few other things. One of which is on line 10 there, for instance, you see the with expression, which is enabled in C#9. That's just a thing for records. And what that does is that it's for the situation where you want to work with an immutable object model, but you want to still make changes. But the way you want to make changes is to create new objects from existing objects with a few things changed. So you create there's the value of what it used to look like, and then there's the value of what it will look like after the change. And the with expression takes the existing person object here and creates a new one that is like the old one, copies the old one over, except for what you show in that object initializer. Right.
This is a technique we often call non-destructive mutation, right, Mads? Where we have an immutable object and we produce another immutable object from the bits of the previous one.
Yeah, that way
it
you
looks
don't
like mutation, but there's actually two objects in play.
Right. Yeah. So you don't destroy evidence of how it used to be. So that's great if you have a record system actually where you want to keep a record of what things were like before as well as what they are now. It's good for like if you want to undo things and all kinds of things. So and in fact a lot of Roslyn is built on similar principles. The C# compiler API. So that was C#9. We did that, and then realized that records are kind of cool, and it's a shame that you can only do it for classes. In some way, they are like structs already. Structs are also value based. They also compare equals based on what's inside of them and so on.
And they kind of have this copy on, you know, by value sort of semantics. So it's still,
yes,
you know, they're still classes. Yeah.
Similar to the with thing. And so, but there are also some things that are nice with records that structs don't have. And so, essentially, we wanted to make it so that records can also be structs.
Right. So the first feature we're going to show, which is kind of, you know, silly, is that you can actually say class here now. The importance of that feature of being able to actually state that this is a class is that now you can also state in C#10 that this is a struct.
Right.
Okay. And all of this code works the same, except that this is never allocated on the heap, right? This is always a stack-based thing, like any struct as a value, which, you know, can be used for, you know, performance benefits, but it just seemed like kind of arbitrary, and they were so struct-like already that it just made sense.
Right. So so the couple of things that that records add to an ordinary struct, you can kind of see. We do a few things here that you can't normally do on structs, like for instance, they define a proper equality operator.
Right. Yeah. Structs do not actually define equals, equals, and not equals operators, but they do define an equals method, right? And so we have that as that. So that works here as well. In fact, I kind of want to run this to see what this does, because we're creating a person here, and then we create another person by changing one field from that one property, and then we create another person from this one by setting the name back, and then we check the equality between person, which is right here, that's Scott Hunter, and this original person, which is also should be Scott Hunter, right? And so this should return true, and this should return true. Okay, I just want to run it real quick so we can see it go. At least see that we're not just playing with smoke and mirrors. Yeah, you can see that, okay, the equals was true right here, and the operator equals was true. And here are the other thing is that these the records give us that we hadn't mentioned yet, was they give us a nice two-string implementation that prints the properties out and the name of the type that we are. It does that for you. So
you can say that two-string is value-based as well. Instead of just printing out some random reference or something, it actually shows the values inside. So so that's record structs. Now would be a good time to ask if there are any questions.
Yeah.
And again, as Sam said, there are no stupid questions.
I've got a question. Can the record struct then have mutable members in addition to like the unmutable ones here?
Yes. Yep.
Okay.
One thing so records and immutability go really well together, but we decided to not make that coupling sort of like a strong language requirement. So you can totally have mutable record members, fields of properties here.
Okay.
In which case, it'll let you do that.
Derek Hunter.
In the case of the person record struct that you have down there, are first name and last name also allocated on the stack, or do they get allocated on the heap?
Oh, yeah, sorry, yes. The strings are heap allocated always, right? They're always allocated.
All right.
Yeah.
Makes sense. Thanks.
We don't have struct strings, though that'd be cool. We do have tricksy ways of doing some of that in C# with like read-only span, where you can create, say, a read-only span of char on the stack. Mm-hmm. But then still everything in .NET is based on system.string, which is generally heap allocated.
Okay, thanks.
Yeah, in general, record structs and structs aren't all that different. Essentially, just like record classes aren't all that different from classes, except that we define some extra stuff on top. We override the equalities and so on.
Yeah, I can even just delete this, and a lot of these features still work on regular structs in C# 10.
That's actually, now that you do that, it's actually, you're sort of like sneak peeking another little C# 10 feature, because it's surprising the things that still work. What's most surprising probably is that the with expression still works.
Yep.
Because, oh, and I see there's a question in chat. I'll get to that in a second. The with expression used to only work for records, and it still works also for struct records. But we decided the sort of core functionality in the with expression is for the value or object to be able to copy itself. And all structs know how to copy themselves. That's just what happens whenever you assign them. So we just made it so that the with expression always works for structs, even your existing structs. And it's just implemented by taking a copy and applying those changes from the object initializer.
I'm just gonna run this, and you can see also the toString changes, because now this is just a vanilla struct. We don't generate a toString method for struct, and the default in .NET is that for toString is that it prints the name of the type, right? So a lot of this is, but equals is true, right? Because structs by default also have, value-based equality, where they're equal by the sum of equality of their parts, right? And so these still end up being equal to one another, though it doesn't implement an equals operator, which why that had an error.
Yeah. That's and I will get to your question, sorry, but just on that point, when we did records in C# 9 initially, part of the sort of design philosophy was do whatever structs do for these value-based behaviors, just implement them in classes. And of course, for equality and the other things, we have to figure out, well, what does that mean when you have equality? How do you make, when you have inheritance, how do you make a value-based equality that behaves well when you can have records that inherit from each other in a class hierarchy? And we figured that out. So it's more advanced, but all else equal, records already, the value-based behavior that records have is already modeled on structs. And so structs and record structs aren't all that different in that respect. So Brad has a great question. What are the uses for a record versus a regular class of struct? I think that really goes to the heart of why we're doing them. And so I think it's this objects versus values kind of thing. Would you say, Dustin, that's a pretty good way of talking about it? So sometimes you really want the object to represent the current, an object that is one-to-one with an evolving thing. It's a model of something that exists in a way, and it has mutable state that evolves over time, but you keep the same object around. And that's sort of classic object-oriented programming. And you typically work with mutation there. But sometimes you find yourself fighting against that. And I think more and more people were telling us, whether they were inspired by functional programming or because they were dealing with data more so than objects, data that maybe lives elsewhere and is beamed to you over the wire, that objects weren't really good at representing that. Instead, you wanted to represent your data as values, but you still want the capabilities of classes maybe. You still want to be able to have multiple references. You want to be able to have inheritance hierarchies and so on. And so representing values as opposed to objects, a snapshot in time, which is why they're very often immutable, even though we don't force you to do so. That's sort of really the kinds of things where people found themselves, I have to implement all this, I'm trying to implement the right equality here, and I'm trying to, people were kind of having to define a lot of stuff on top of their class declarations just to get the right value-like behavior, overriding equality all the time and get hash code and so on. And we were like, hey, we can do it for you with a language feature. And that's what, that's sort of the core difference there. Dustin, you're typing something.
I am. And some of the things around records, there are other features that are really nice. And for example, this sort of thing where I don't have to just, it looked very much like something you would type today with kind of nominal properties there declared separately. But there's also shorthands for records that add value, so whether they're classes or structs, where I just want to have a class. It's just a plain old object, right? Just a POCO. I just want to have kind of a little bag of data. This is often, it's very common to have, a small hierarchy of objects as you're passing over things across to represent data on the wire in a protocol or something like that. It's just very convenient. There's also kind of a convenience to records that I think is really valuable. That, this would, there's a lot of boilerplate that they kind of remove for some of these scenarios.
Yeah, if you think about the example you have there, well, we call this a primary constructor.
Yep.
And essentially, by putting that constructor parameter syntax on the record struct or class name itself, rather than declaring a constructor, you're not only declaring a constructor implicitly, you're also declaring those members. I mean, you can declare them yourself if you don't like the default ways that we do it for you. But otherwise, we'll declare some for you, some public init-only properties there. And we also declare a deconstructor in case you want to use deconstruction on the values. And essentially, it's just like all the value things you might want to do with something that has these data members all gets declared for you. So it's very much about convenience as well.
Right, so you get this automatic deconstructor, so I can deconstruct person into its properties, right? Then get those out and assign them into locals, for example. And this is something you just kind of get for free as part of the machinery that we generate for a record.
I don't know if you all know, but you can declare your own deconstructors since C# 8 or 7.
Yeah.
That let you do that, but we'll do it automatically when you have a primary constructor on your record. Okay, can records constrain generics? Yes, there's no difference there. Records are just classes or structs. Structs generally cannot constrain generics because the struct would be the only type satisfying that constraint. So we generally disallow trivial or meaningless constraints like that. But
it's not a valid constraint. Oh.
But if we had a record class, then absolutely.
Yeah, sorry.
No different from other classes in terms of generics. There's one thing about class records that is a little annoying, and we haven't solved it yet, but we want to someday, which is that you can't.
Our future selves are always smarter, right? So.
Yeah, well, you hope. Or we get replaced by other selves that are eventually. But the class hierarchies can't mix records and non-records today. Like if you have so records can only inherit from records, and non-record classes can only inherit from non-record classes, with the exception of object, which they all inherit from. So they can all implement interfaces and stuff, but when it comes to inheritance among classes, we limit that. And that has to do, there's no philosophical issue there, but it has to do with the intricacies of how how equality works and how it's implemented in the records across the inheritance hierarchy. And sort of interjecting non-records into that confuses us too much, and we can't really handle that. There's some magic going on that eventually we could make non-magic and surface in the language, but today we preserve the magic by not letting you have non-record classes in the hierarchies with the records. That's a bit of a limitation, not probably so much in practice, but and we to be honest, we don't hear many complaints about it. People don't come to us with scenarios saying, why can't we do this? But it hurts us. It hurts our souls that we have this limitation. We might eventually do something about it.
We're always trying to solve the next thing, right? And some of them are hard. That one got away so far. Yeah.
Want to go to the next question? So Joe says a record would be useful to pass. Oh, are you explaining to the previous question? Maybe would be useful to pass in as a parameter to a method. The method could easily copy it and fill in any missing values for itself and not pass those changes back to the calling method. Yeah, that is true. That is using the non-destructive mutation. That's one of the great things about non-destructive mutation is that yeah, you've made your object impervious to change, and you can freely pass it in. You don't have to pass defensive copies or stuff like that. And the only way that the receiver can mutate it is using with expressions or creating a copy of it, so they're not affecting the original.
Yeah.
We rely on that heavily in the Roslyn API that I mentioned before, our API for C# and VB, the language itself, in order to ensure that you can freely pass around subtrees, language, syntax trees and whatnot, and everything's completely hygienic. Nobody can mess them up while they have them in their possession. Yeah. It also helps with concurrency, so we can parallelize a lot of things, because when the objects can't change, you don't have to worry about shared mutable state. You're not looking at something that all of a sudden changes in the middle of you looking at it. Like that just doesn't happen. So the immutable programming that records help with is really useful for many things. Yeah. Stephen is saying, I could see using records instead of classes for DTOs. Yeah. Eric says, I really want to use the with syntax in generic. Can you expand on that? You essentially want to constrain things to something that you can use with on. I see. Yeah. So you want to be able to constrain something to being a record so that you can apply the with operator to it in the generic context. I see that. I wonder, can you actually, when you're constrained to a specific record, can you use the with expression there? I'm not sure. Do you know, Dustin? Remember?
I mean, I would expect it to.
Let's say we had a T that was constrained.
Let's go back to this guy right here.
Yeah.
Can I, pass in, say, whoops, I have insert mode on. If I pass in some person here, can I say this? Of course I can.
Looks like you can. Yes. So if you are actually constrained by a specific record type, then you can.
Well, and the cool thing about this is, yeah, it's constrained to, now it's a little weird to do this because it's not an interface, right? So it's a little weird. I mean, this is almost functionally equivalent to doing this, right? But it does work.
Yeah, it does work. I mean, you might be doing other things that requires it to be generic. Like you might be returning one of your own kind, and you don't want to lose the fact that when you call it, it was actually something more specific.
Right.
Yeah, it does work.
Yeah. And because we have it down here, we still could also actually, you know what, let's mess with this a little bit. Let's do it like this, and we could still say call this like so. We'll say student XY. They're very, very good at the grades.
Good.
And we're passing in a student, so it's a subtype of person, and we're going to get back student as a result. And this transformation will work because with expressions, as Mads was talking about earlier, they take into account what the actual runtime type of the thing is. So it's not statically we see that it's a person, but at runtime it's a student, right? And so when that with expression runs, it does in fact produce a new student if that's what's passed in.
Yeah, it doesn't have the sort of accidental data loss that you could expect if we were doing the copying directly in in source code, right, where you only statically know that something is a person. That goes for that regardless of being in the generic context here or not. In general, with respects the runtime type of the source object, and it creates another object of the same runtime type, copies over even all the members that you can't see because you didn't know that it had them. It still copies them over. So it's a very faithful copy. Essentially, you can sort of think of it as there's a hidden method in the record that is virtual and that does the full copying. That's pretty much how we implement it.
Yeah, but I can't use the GPA here because, of course, it's constrained to person.
Yeah.
Right? Yeah. So Mads Christensen is just going to have a 2.5 GPA.
Yeah, sorry about that. Just because you'll inherit my GPA.
Yeah.
Let's see. Dave says, how heavy memory-wise can a record be before it starts impacting performance? Yeah, so records and performance in general are a really good question. So records so from a memory perspective, again, record classes and record structs are just classes and structs. They don't have different memory profiles themselves as types.
Right.
So you have the same trade-offs between class and struct, whether it's a record or not. Where it gets different is that these value-based behaviors that we implement on top, they do generally have a higher performance hit than reference-based things. Like doing equality by examining, recursively calling equals on all the fields, that takes more time than just comparing two references. So it's important to realize that you're taking a performance impact. And just because you're essentially, by saying record, you are asking for more stuff to happen. And for that stuff to happen takes time. So that is sort of like an important thing to remember.
It's unlikely that it's anything that would show up for you, I would say, though. There's probably going to be deeper problems with your code before the equality generated for records shows up as a hotspot, would be my guess. In the general case, I would say. I know there's edge cases, but in the general case, it would be, I can't think of a case in my own code where I'd ever have seen equals being the problem.
The usual advice around performance is measure.
Yep.
And when you measure, this is not typically the thing that'll show up as being, oh, this is what's bogging down my application. But maybe in tight loops and stuff. But the thing is, we implement these behaviors as efficiently as we can. So if you want the behaviors, this is what it takes. If you want value-based equality, that is what it takes. And there are some less obvious, but still sometimes important performance wins you can get when you go immutable and use records. We talked before about not needing defensive copying. So that's a performance win right there. And being able to parallelize without risk, that's also often a performance win. So so again, using Roslyn, that's where we got most of our own experience with immutable programming from. Even before we had records, we sort of just simulated them. We found that we were often able to balance out some of these overheads with wins elsewhere because we were immutable. So it's complicated, but at the heart of it is, yes, records do more for some operations.
I think, are we out of questions now?
I think so.
I think so.
Yeah. And again, feel free to also ask questions with audio. I understand, Eric, you specifically can't. But everyone, just feel free to just pop on and ask a question.
One thing I kind of wanted to bring up that I think is super cool. I'm gonna kind of roll back to this sort of initializer where we're initializing with an object initializer. I kind of want to get back to these fields down here. real quick. But we found that the with expression is a powerful thing, and we've spent a bunch of time talking about how we could make it even more general. Could we make it so that you had some sort of pattern that if you followed, you could make it work for a regular class and that kind of thing? And I don't think we've landed on anything quite precisely there yet, but the things in the language that kind of look like records, or at least they look like immutable things, they look like values, we've tried to make with expressions work on them. So you saw earlier that that regular structs now with expressions work on them because they create a copy. Comment some of this code out, right? But also another thing they work on is anonymous types, because anonymous types are in fact immutable and in C#. And so now I've just deleted the type name, so now there's an anonymous type called person. It's no longer that record type down below. But all this code still works because we, in C#10, again, trying to expand some of these features. We don't like having features that aren't sort of general purpose. We like them when you can express yourself in the same way across more of the language, as opposed to having kind of little corners of the language where you use certain features. And in general, we like to do that if we can, and especially if it makes sense. And with is such a powerful thing that we made it work on anonymous types as well for C#10. I think that's pretty cool.
I agree.
All right, we did some other stuff with structs too, Mads. Do you remember?
Oh yeah.
Yes. Yeah. So, yeah, and some of these are they're new, and they're some of them are I don't know how I want to say this. They're kind of like things where we had protections built into the language around structs because they can be confusing, right, to use. And we've kind of decided that there's been enough water under the bridge that we can relax some of these things a little bit now, right? And so the first one here that's brand new, other than the with expression that you saw up there, but also other things that we've added are public parameterless constructors for structs. Today you can't do this in C#9, but in C#10, sure. And of course, as it's a struct, we want to make sure that these are initialized before the constructor is finished. So this is brand new, and it's convenient and it's useful. There have been all sorts of cases where this has been this gets in the way, but it's kind of a protection. And the reason it's a protection is because now there are two ways to when you initialize this struct. So I could say person, right? Because it's a struct. Why does this give me? Oh,
it's because you are after.
Oh, because I guess. Sorry, top level statements needs to be up here. Sorry, thank you. So I can initialize. Yeah, and so I can initialize the struct this way, and it will have those properties assigned, right? But I can also initialize a struct like this, right? Where I use default of person, or I just, I can, and in that case, it's different. And
yeah, those things used to mean the same thing.
Yeah, these things were the same thing, but now that you can declare these, they might not. Because default is going to mean give me the default of the type, kind of everything zeroed out. So if it's a reference type, you're going to get null, right? Every time. But if it's a struct, it's going to be, a bit of memory of that size, like that the struct has, filled all with kind of in memory zeros, right? Just like the reference type is null because it's all zeros. So in this case, we get a person with a null first name and a null last name, right? And then in this case, we get John Doe. So that's a new feature of C#10. That's it's just something that this was here for protection, so that these weren't different. And we kind of decided that the value now, it kind of tips us in the direction of saying, well, maybe this is okay now.
Yeah, I think if you all remember C#1, right? That's only 20 years ago. And
I do.
C#1, we didn't have the default keyword, so the only reasonable way
Yeah.
that the language could offer to create a zeroed out struct was to occupy the parameterless constructor syntax for it. So that's what it was in C#1. And in C#2, when we added generics, it became useful to have a default keyword anyway. And now there were these two different ways of creating a zeroed out struct that we never really dared to differentiate them. Actually, you've been able to do this in IL all the time. Like, it's a C# restriction. It's not a restriction in the underlying platform that structs can't have parameterless constructors. So we would actually, if there was one that was created in IL somehow from a different language or somebody just tinkering, we would respect that. Like, these two, P1 and P2 here, are already different in that sense, that if there is a struct with a parameterless constructor, we will call it in the first case, but not in the second case. And that's been the case for C# forever, just for interrupt. But now in C# you can author a struct with a parameterless constructor. So it's going to be much more common.
Right. Where this gives us a lot of value, though, I think, is, I might not often be writing a public parameterless constructor for a struct, but one of the restrictions that kind of falls out of not being able to use a public parameterless constructor on a struct is that I can't have field initializers, right? And so that's something that this brings to us, is the ability to do this, right? And we could write it this way.
Yeah, you do need to declare the constructor as well.
Oh, right. That's right. I do need the constructor, however, and that's something that's changing. Is that right?
Yeah, we messed it up a little bit in the first first release. So we had a little panic around this, but you do need to declare a constructor in order to have field initializers,
right?
Because otherwise they will never run. But the first, this might still be like, I don't think we've released the fix.
No, we haven't released it yet. This is a recent design decision. So when we shipped like this, and basically you could write this and we would generate a public parameterless constructor for you, so that when this happened, it would do the right thing, right?
Yeah.
And now we're going to error, I believe, on that case where you have a field initializer, but you need to add a public parameterless constructor if you're going to have field initializers.
You need to have a constructor. That's all.
You need to have a constructor. Right. Exactly. So I could have another constructor that was like,
yeah. Yeah, we will never generate a constructor for you if there isn't any.
Yeah, that was actually, yes, of course that's what's in the product, Mads, because we literally talked about that in the design meeting 2 weeks ago.
Yep.
So that's fresh.
That's how we do language design here. We design the features after we release them.
All right. Well, let's move on to some other stuff. So we've been kind of gnarly in records and structs and allocations and all that sort of thing. But we've got some other really cool features to look at, because as we've been writing this code with top level statements and doing all sorts of things, I mean, that this code looks really different from C# 1.0. It looks really different from C# 3.0, right? It's because we're trying to reduce a lot of boilerplate and clutter and things that just kind of get in the way, right? And another bit of clutter that's kind of, we'll say, infected every C# file ever is this right here.
Yeah.
Right. That blocky using directives. And in C# 10, and a lot of you probably heard about this, but we have introduced global using directives, which are essentially using directives that can be applied throughout a project. Okay, so I come here and I actually have a bunch of using directives. These do nothing so far because there's no code in this file, and they gray out as you would hope in the IDE. But if I come in here and I type global in front of them, now a bunch of them light up because they're being used elsewhere in our project. So if I go over here you can see now these things are grayed out, right? Because we don't need them anymore. We're already declaring those throughout the project, and now we can clean up even further, especially by having, some of the common namespaces that get used already declared here. But also, we could have our own things as well that are, that maybe are parts of my project. I want to make sure that I use them throughout. Okay. So if I had something like in model, if I had something like that, I could go and then use I could use that throughout my project, and then I wouldn't have to declare at the top of every file. That's fantastic.
Yeah, I think that we started out 20 years ago, and I say we in a very general sense because neither of us were there at the time, giving people very fine-grained control of this. What exactly is in scope in this file versus this file versus this file.
Right.
And what we find is that is actually rarely very useful. And what it leads to is a lot of bookkeeping. And the IDE actually, in its attempt to help, sometimes almost makes it worse because it grays out the ones that you're not using and offers you a refactoring to say remove unused usings or whatever. And now you're tempted to clean up your file, and you end up with different lists of usings in different files. But of course, at some point, you're going to need something that was on that list, and now you have to put it back. And, so there's just a whole lot of bookkeeping around the usings that isn't really useful. So for people who are okay with having the same, at least core set of usings across all their files, global usings they're just really what you need.
Right. And so now, and of course now over here, I put that, so I moved that person type into its own file. I put in another namespace called model. And over here, everything is erroring that tried to use that, right? So I can come back here like I was doing before. So let's go ahead and push that there. And we see that everything lights up, right? So
Yeah.
I could have, this is something I could do in my own thing. I could just have all of my, my object model all in one namespace and then just put a global using for it. And you're good to go, and you don't have to have all those extra using directives. So cleaning up boilerplate is kind of a nice thing in C# 10 as well. Another piece of that, which I think is especially cool, is that is because there's an atrocity that's happened over the years, Mads, and that atrocity is that we have basically caused every single C# file in existence, I think, over the years, most of them, 99 point some nines, right? Some set of nines. We've caused each one to be indented with a namespace.
You want to go there?
Yeah.
Can we wait a second with that? Because I think we have a little more on the usings that we can.
Oh, yeah. Okay. But let's.
Could we have a question to start with in chat? So there's a question: would there be any downside to just moving all usings to global as long as there are no collisions? And the answer is no. There's no downside. The only downside is potentially collisions, and those happen very rarely, it seems, in practice. If you have a collision, there's usually the trick you can do where you can have a using inside of a namespace, like in a given file, you can put usings both outside and inside the namespaces. And the global usings are as if they were written outside. And so if you want to put something in front of the other, you can use that slot inside of your namespace declaration to make one the one that will be resolved to. So even then, if the collisions are rare and you just have a few places where you want to resolve them, there are ways to do that. So yeah. Mostly file-based usings can just be gone. But there's one more thing with the usings, which is that beyond the language, the templates.
Not a language feature, right?
Not a language feature, but now that we have this global using language feature, templates in Visual Studio or in .NET used to put usings in every file according to what the template said you probably would need. And what they do instead now is actually that they generate an extra little C# file. They don't put it in your directory for you to edit, but they just generate it on build and compile it alongside with all of your code, so that these global usings of the things that are considered the default namespaces for this particular template, they just happen. You don't see them anywhere in source code. They're just there.
Yep.
Now this is obviously it's a slightly intrusive feature, so you can turn it off, but I believe it's on by default.
Yes, it isn't on by default in this one, and it won't be on by default in anything you already have that already exists, right? But if you move to .NET 6, the .NET 6 SDK, you can turn it on by enabling implicit usings, okay? And so that will then actually cause everything to be unnecessary. I should be able to basically get rid of a bunch of these, right? And I can even go in and I can add new ones, right? I could add my own to the list of namespaces that get using directives, global using directives generated for them. I can come in here, I can put my model namespace in here. And so now, I believe, Mads, if I'm right, I should be able to delete all of this if it works. We'll see if the demo's good. It's been a while since I've...
The using static is not there probably.
Oh, you're right. The using, and that's exactly what we see.
That's where the only squiggle you get.
So that's going to be the only squiggle we get. So if I go in here and I say, you know what, let's just delete everything except that one.
Yeah, the top 6 come in just from the template, and the bottom one, you added that. Now, Why would you add it in there? Why wouldn't you just have a global using on your own?
Well, yeah, I mean, I think the value of this is that I can then, now that it pushes into MS Build, I can have, my build set up at different folder levels if I want to. I could use a directory build props or something like that to decide that I could include a namespace into multiple projects if I wanted to. And I can do some things that are a little more, outside of the current compilation.
Right. So the tooling makes use of this new language feature as well to take usings even further out of your hair.
Yeah. And hopefully just, hopefully no one will ever see. I think the thing I'm going to be most thrilled about is that in a few years, you'll never see system link again. Just the methods will just be there. You won't have to add it or forget to, I removed the using for that, and now, to list or select or where isn't there anymore, right? It'll just always be there. I think that's exciting.
Hey guys, I got a question.
Yeah.
So this is probably more of a Visual Studio question. So your implicit using you have in your program file, or your project file, excuse me, will that be honored in the rename refactoring if you decide to rename that namespace?
I don't know. It's a great question. Nope.
That's it. Actually,
nope.
I mean, that's a really good question. It's a good one to change to look at. I think the problem is there. And who asked that? I'm sorry.
This is Tim Graham.
I think the reason for that is that MS Build logic can get very complicated, right? And so we would not be able to chase that down. Like, it's very simple, obviously, in this project file right here, but as soon as you pull that out into another MS Build file, some other target, or maybe a target runs that generates them, it gets to a place where it's actually impossible to trace down. So I suspect that won't happen. So for what it's worth, from a tooling perspective, I think it's extremely hard to do.
Yeah, that
makes
a lot of sense.
Yeah.
I guess you just offered a reason to use
the global usings.
Global using instead of the project file if you're just within your single project.
Yeah, and there's multiple ways to do this, right? You could just have a loose file of global using somewhere that you just link into every project, or put it in a shared project, right? The shared projects in Visual Studio that just all they do is kind of link files statically into each project that references them. You could put a global usings file in there, and it would just get pulled in everywhere, and then your rename would work. So there are multiple ways of doing this. But yeah, we decided to give you a choice in this case.
Cool.
And
Thanks.
yeah, absolutely. And another value of the implicit usings is it'll actually generate a different set of global usings depending on the domain of the project that you're working with, right? So if I create a new ASP.NET, project, or I create a console app, or I create a WinForms application, these are going to be different, right? The set of things that are kind of globally used, that are most useful for working in that domain. I think that's especially cool when using implicit usings.
Okay, any more questions on the usings, the global usings and implicit usings? All right. Dustin.
Yeah, back here.
There you are with your ultra-wide monitor complaining about indentation. What is up with that?
Well, I'm running not ultra-wide right now, so I've got this down so it's not too big for everybody. But the indentation is offensive to me, right? It makes it sprawl unnecessarily horizontally. And it just feels like, I don't know, we're wasting space, especially in a version of the language where we're doing things like global usings, where, I get rid of these things, right? But now I've got so I've taken care of some vertical space, but now I've got horizontal space to deal with. And the thing that's extra frustrating is that 99%, I'm just going to be conservative on this, of C# files contain a single namespace.
That is exactly right. We went and looked on GitHub, like just the public stuff.
Yep.
And it is literally 99% of C# files where the file has all the declarations inside of a namespace, and it's the same namespace for the whole file.
Right.
So that means that now that we got rid of the usings above the namespace and all that stuff, that means that all lines but 3 are indented in every file.
Yeah.
That is annoying.
That's very annoying. So let's do something about it, C#10, right? It'd be nice if I could just do this, right? Put a line up there for clarity, and now I don't have to indent. Yay! So FileScope namespaces is another part of kind of removing clutter in C#10, and it can things start to look really pretty. I just converted a whole code base to this, and man, it looks beautiful. It really does. It's this sort of thing where my eyes, when we introduced expression-bodied members, and I found like everything starting to compress, where I had all of these, just single line methods and properties, and they just kind of compress back in C#6, and it changed the look of C#. This for me is also changing the look of C#. It's pretty cool.
Yeah, it's a pretty big facelift, and it's interesting. You can sort of you can argue, and we did, is it really worth it? But once you see code like this, it's just like you realize how much your mind has been sifting out clutter. And now more and more you can sort of just focus on the core thing, the actual logic in the file. So that's been a trend for a long time, at least since the expression-bodied members, and almost every release of C# has something that helps not just shrink it in sort of like convoluted terseness fashion, but just get rid of clutter. And it's, C# is an old language by some standards, and this is one of the ways also just to keep it feeling modern. Like what was an expected sort of typographical overhead 20 years ago isn't that anymore. And so making the language fresh and clean by modern standards is also part of what we do.
Right. And there's also the thing, with this where it's just like kind of removing clutter in the absolute, the overwhelmingly common case, right? I mean, yes, there's namespaces are kind of tricky declarations. They can be nested and have multiple nested ones, and their names kind of get added up as you go up the declaration tree. and all of that. But it turns out that those don't really appear. That style of namespace doesn't really appear that often in the wild, and so this just covers that common case in a beautiful way. I love it.
Yeah, I think that, I mean, we talked about it before with the usings as well. In C#1, I think that we were careful to make sure that there was enough expressiveness.
Mm-hmm.
And in some cases, we hit it just right, and in some cases there was too much generality or there was more than anybody really needed. So everyone's been paying for this generality with indentation, but almost no one made use of it. Like certainly less than 1% made use of it. And so you still can, but I think in those cases we should and will continue to give you the easy option for what is by far the common case.
Yeah.
Awesome.
All right.
There's actually a question about if we're done with the file scope.
Yeah, I think we're done with the clutter stuff. There's a question around what's the furthest one back? There's a lot of chat. I see the one about async await. Any new features there?
I think that's the last one that was a question.
Okay.
The first one that was a question here. Yeah, there's not much. That's a little bit like async is one of those features that was like a really big blast, and then we've mostly just been polishing the corners of it ever since. There was a fairly big addition in C#8 when we added the async streams. You can do the async for each and async enumerable and all that. That was like a big
disposable as well. You can have async disposable too. Yeah.
So that was sort of the last big push around async. The thing that we did do in C#10 is a small one. There are these features that our library authors keep asking us for, which is we want more control over what the compiler generates. And there are these async method builders that you have been, now for a while, you've been able to put attributes on your various declarations to have the async code generation use different classes for some of the functionality. For optimization purposes and that kind of stuff. And mostly just the BCL uses it. And there's been a little more evolution there, again in C#10. Essentially, you can do it at a method level that you could only do at a type level before. But that's the only thing that is async.
I'm going to go ahead and bring this on screen. I mean, for folks who don't know or maybe haven't delved in here, but all C# is designed in the open. Right, and this is and Roslyn is where the compiler code base and the accompanying IDE editor experience is open as well. And so we track language features there. The compiler kind of tracks them for implementation, that sort of thing. And so we actually have features here that we're looking at that may or may not make it into C# next, but are in progress. And here are the features that are in C#10, and some of them, they're a little esoteric, and some of them aren't really language features. Again, this is work being tracked by the compiler team. So like source generator version 2 APIs, not really a language feature, right? But the async method stuff that we're talking about here, you can delve into that, and there's a whole proposal for it. Stephen Tobe, like if we're talking about libraries, there's no one more libraries than Stephen Tobe, who's the owner of the BCL. So and he's the one who proposed this, and where a lot of the discussion happened, and we drove it through the design meeting. And again, that's the one thing for async and await, which just allows library authors to have more flexibility. So from your perspective, there's no new feature that you would use, but there might be something more, I guess, more interesting happening under the covers, under the hood.
So there's a bunch of stuff on this list here. I wonder if we should show one or two more. I would definitely, I think out of these, the largest remaining one is probably the Lambda Improvements.
I know, and it's so hilarious here, Lambda Improvements. Like, that's like the understatement of the year for what happened with Lambdas, right, in this release, because it was, for us, it was kind of a head scratcher. But yeah, I've got some code here to do some of that. So looking at lambdas, right here. And I think the big news for C# 10 is that kind of at long last, you can type this.
Yeah.
And I can actually hear you all cheering from Ohio out here right now. I can actually hear that. And so what we've done is we've given Lambda expressions a natural type. And we finally decided that action and func, we'll accept them as these are the types of lambdas. And so you no longer have to constantly be helping the C# language along by annotating with that type. If you didn't put one, we'll try and pick one.
Right? Would you mind hovering on the variable there?
Yeah.
And you can see that indeed, yeah, it looks even nicer if you hover on parse instead of on var. Then it's going to fill them in.
Beautiful. I thought that was beautiful.
You can see that it just figures out, obviously, this should be a func of string, int. That's
right.
We can see that a string comes in because you were nice and gave us a parameter type in your lambda.
Yeah,
and we can figure out from the body that an int comes out. So why make you say it?
Yeah. And if you don't put that type, that's fine. It's going to be an error because we can't figure out what S is.
Yeah.
Right? It's difficult to do. Parse has multiple overloads that take a single parameter. Right? It could be a single parameter like read-only span. So we just don't know what it is. So in that case, we'll error if there's not enough information. Dave Heineman, that is a troll. I appreciate that. That is quite a troll.
So
yes.
Yeah, so in general, we'll try to figure out what type you meant. If
Right.
you look at the next one, you want to say more about this one?
Well, there's a couple of nuances here. I mean, here we're inferring the static type of this thing, and it's getting assigned into var, so the type of parse is var. But remember, delegates can be always upcast to object, right? And so it will also assign that now object is parse, but it does contain a func of s to int. Okay. Other types that delegates are convertible to, like in fact delegate, same thing. That will also work,
yeah.
Right? Which is important for the future. In fact, one that I think is quite interesting is this is also legal, right? If I have system link expressions, now it's an expression tree.
So even though we don't have a precise type, the fact that it is one of the base types of expression of T, that provides enough of a hint to the compiler that it will go and figure out exactly what expression of T it should instantiate for the lambda. So it knows to make an expression tree instead of a delegate, as long as you use one of the expression specific base types of expression of T. So it'll infer expression of func of string, int here.
Yeah. Now you wanted to go down to the next one, and the next one's rather interesting because in this case, if I use var, there's not enough information to figure it out, right? We can't infer the delegate type. But that leads us to an
input type, not the output type, because it's
well, right. We have the input type, right? But because this expression is now, well, it could be a string, it could be an int. It's not any, Dave, but in a statically typed language like this, we'll say, sorry, we don't know. In this case,
yeah, we need something more to go on.
Yeah, we need something more to go on, and so in C# 10, we can give it more to go on. We can give a lambda return type, and that's new.
Yeah, it goes in the same place as return types on local functions, just before.
Yeah, in a way, we're kind of making, we introduced local functions, which had all this ability to do some of these kind of like have return types and all that kind of thing. And now we're doing some of that with, kind of bringing lambdas kind of closer to the functionality that you can do with a lambda expression. We're bringing it closer to local functions.
It's not inconceivable in a future version of C# that lambda expressions and local functions will have almost completely will have become the same feature. Like we're generalized in the direction of each other so that they're really the same feature.
Yeah, from a semantic point of view, local functions becoming named lambdas, as it were, right?
In fact, one more thing that you can do with local functions but haven't been able to with lambdas is put attributes on them.
Yeah.
And we added that as well. So a lambda in C# can now have an attribute on it.
I can put it here, right? I haven't done this before. So I could put like some existing attribute like CLS compliant, which nobody does anymore, but you know, it exists and I know it's there. But we can apply that now on a lambda, which we could not do before, but you could do with a local function.
For the longest time, there was a sense that why would you put an attribute on a lambda? Because it's immediately converted to some delegate type and then the attribute is gone, right?
Right.
But there are still ways. So it can't really matter to sort of like consumers of that delegate variable because it disappeared, but there's still ways it can matter. One way is in the compiler itself, you know, we sometimes use attributes to say something about what happens inside of the thing.
Can I do a return here?
Yeah.
Or I don't need a return, right? Or,
you do if you want to talk about it depends. But I don't know what attribute you want to put on there.
I was thinking about adding like
maybe
like
null.
Yeah, that sort of thing, like adding some of the nullable attributes if that were possible to do. I can't think of one right now, but that's the sort of thing that you can imagine where you have static analysis tools that might make use of an attribute from, you know, looking at your source code.
I think if you put a return colon on it, then that would probably work. Yeah.
Yeah, I was just surprised the attribute specifier wasn't showing up, but yeah, there you go. So, and there's something that it doesn't matter what it compiles to so much, it's more about the static analysis that happens at design time.
Yes, and then the other place is, of course, that the attributes are generated onto the methods in IL and exist at runtime and are queryable through reflection at runtime.
Yep.
So that's another way you can get at them. And this is all of this that we've shown right now. I think it's important to mention that we didn't just do it because we feel like it now. I mean, there was a specific project that drove us over the hump here, which is ASP.NET's new minimal APIs. So where the idea is that you can essentially just have a map, map get, map put, whatever they're called, and just have one overload that takes a delegate, so that weekly type delegate that we showed before, and then you can pass lambdas to that of different shapes, and they would actually get generated at runtime with different delegate types, and then through reflection, that one method can pick it apart and do the right thing. And if that gets too expensive at runtime, we can optimize by using source generators. We can source generate overloads based on the way that you call that method, and put some overloads in place that do all of that at compile time as well.
ASP.NET has gotten so fancy.
So it's super fancy. It's surprising. It's really neat. So we had a really good collaboration around this. Like, they're simplifying their APIs. We're doing the next level cleanup in C# as well. And so together that makes for a whole new experience of using it.
And that source generation gives them, you know, performance improvements. They're not necessarily using a lot of reflection there. They're generating the code that gets statically compiled to do what you wanted.
So that whatever they're called. Yeah, sorry.
Sorry, I felt that it was nice. It was appropriate to troll you in the chat. Now method groups like lambdas are a thing that a surprising number of people I talk to don't realize this is possible, right? That I can take a method group is where I take you know, a method and just it's a group because we haven't defined an overload here, right? We haven't specified an overload. This is the sort of thing you do when you assign a delegate, right? But you can assign them here. and we can assign it to a func of int, and that will match that particular overload of console.read. Another thing that I noticed that people don't know that you can do is that you can combine method groups sometimes, and do things like that are kind of crazy. But anyways, but method groups, again, they're another area where we weren't inferring a type. We depend on that type being there, and as we're doing delegates, we're doing lambda inference, we made it possible to do this as well. So we can say var here, and again, we'll infer that that's a func of int because there's in fact just one overload of console.read, which is why when I come down here, this isn't going to work because as everybody knows, there are 17 overloads of console.write, and we just can't figure out which one to pick, right? So we can't infer a delegate type. But like lambda expressions, method groups can also be inferred, which is kind of cool.
And it's important again to note with the local functions that they are an example of a method group. And they can't be overloaded, so there's always only one with that name. So that's an important use case where if you switch between lambdas and local functions, if you move between those two, you get the same functionality mostly. The one thing that local functions can't do is they can't be translated into expression trees. That's not something we have on the docket for the foreseeable future. But as long as you're in the delegate universe, you can pretty much do the same things.
Yeah, there we go.
Yeah, that's another way of doing it, I guess.
Yeah. I actually hadn't considered that, Matt. See, that's actually an interesting point, that local functions, because they can't be overloaded, they just kind of always work with this, which is really nice.
Yeah.
So.
Okay. Any questions on the? I didn't see any kind of flyby in chat questions about the Lambda stuff.
Just please, that troll from Dave.
Well, it was that. That wasn't a question.
No, but I went back to it again and again, so it was,
Yeah, it's delicious.
Yeah. Anybody have any questions before we move on to the next thing?
I hope you're all awake out there.
I know, it's 8 o'clock, I think, right? So.
Yes, yeah. Yeah. It's Chardonnay o'clock or something.
Dude, not Ohio.
Okay, at least people are awake enough. Some people are awake enough to say that they're awake. So that's
good.
Okay.
Well, let's move on. So we have kind of one more big feature to kind of talk about. That's big in the sense that it took a lot of design effort, and the impact is actually kind of significant. But hopefully, unless you're a library author, things just get better for you, and it's kind of transparent, right? Because in C#6 we introduced this incredibly powerful feature. We introduced interpolated strings, right? With the $sign up front and then the interpolations in the middle, and these turn into kind of really highly readable string format calls. However, kind of an unfortunate side effect is that these can bring a lot of cost in terms of hidden allocations. And the fact that interpolated strings, they actually get constructed eagerly, which can be, a little bit of a problem in some cases, where suppose I have something expensive I want to do. Inside that interpolated string, what's going to happen immediately to construct the string, right? If that's inside one of the interpolations. So for C#10, we've introduced kind of a new library pattern that we call interpolated string handlers, that a library author can take advantage of to essentially get, instead of getting the constructed string, to get an object that contains all the parts of that of the interpolated string, or how that would be constructed, and then that method can do what it wants with it. And so we've got a bunch of library types that are doing this already. So here's Stringbuilder, and it actually, and you can see that the append method here takes an append interpolated string handler, which is a mouthful and looks a little crazy. And I kind of wish we did some better IDE support around kind of hiding this and making it look magic. But essentially what this is it's a ref struct that gets passed in, so it winds up being very efficient, that represents the interpolated string and the expressions that will go into the interpolations into the holes, right? Because this pattern right here, I have seen all over the place prior to .NET 6, and it's unfortunate that it's actually surprisingly, it can allocate more than you think. What I would expect to happen is I could create a new string builder here, and when I append and I add an interpolated string into that, I would expect that it's going to use the builder that I have that I'm passing it into, but it doesn't, right? What it does is it calls string.format right here, which under the hood potentially uses a different string builder to build the interpolated string and then pass that into the append, right? So we wind up with kind of a hidden allocation, okay? This interpolated string handler we've added into the library instead does what you expect. So starting with .NET 6, we've added some of these into the libraries so that when I call append here with the interpolated string, it doesn't eagerly construct the string. It just passes in the string parts and the expressions, and then the string builder append method there takes that and it uses that to construct the interpolated string on itself. So it uses that same builder right there.
Yes.
Is that okay explaining that, Mads?
Yeah, I like that. Yeah, essentially turns it into 3 appends, right? So
yeah,
essentially that interpolated string builder takes over. The compiler does an intricate dance where it talks to it and lets it decide what to do with the different parts, like the alternating like string constants from the literal and things in the holes. It passes those to the builder one at a time and says, hey, what do you want to do with this? What do you want to do with this? And what the append interpolated string builder does is to say, I'm going to append that. I'm going to append that. I'm going to append that. So
yep.
The interpolated string itself never comes into existence as a value. It becomes more of sort of like an instruction set to the interpolated string builder, or string handler for what bits. It's giving it bits to consume in a way. So it's very it's advanced, and writing one of those is a little tricky, and you're never going to have to. You just get the nice effect that when you call an API that has one of them on it, it's going to do something better with your interpolated string than what would have happened in the old days. Yeah. And this is one example where it's really just about performance. But the next examples
even more so.
Sort of edge a little more into where there's some semantics involved as well.
Yeah, this one is even better because on a debug assert, even if this condition is true, right? Because it's going to call debug assert, so it's got to, prior to .NET 6 and C#10, it needs to evaluate this expression to pass it into the method called to debug.assert. So even when this condition is true, this gets constructed, and if this happens to be expensive, well, you're going to wait to call that debug.assert. So you pay for it every time, when the only time you care about paying for it is when condition is false, right? And so this is this is another place where we had these sorts of just expensive performance issues that were kind of hidden. And so now debug assert in .NET 6 with C#10 will take an assert interpolated string handler, and the job of that thing is to not evaluate this when you pass it in, and only evaluate it. Then debug assert only evaluates it if condition is false. So now this whole expensive piece just kind of goes away, and by virtue of having debug asserts, like in your code, if you had a bunch of debug asserts, your program might even run a little faster than it did before, just because. That's the sort of thing I'm super pleased with. I love this sort of feature. We just kind of make things better, right? Without a lot of cost to you. You get to continue to use the feature with its same expressive, expressivity. Is that what I'm looking for?
Expressiveness?
Expressiveness. Thank you.
I think that's the word.
I think that's right. Yeah.
Yeah. So it's very. I mean, this is supremely magical when you think about it. Not it. You know, the interpolated string handler here is not only is it telling the compiler, don't bother even evaluating the rest here because I don't care about it, but it's telling it based on one of the other parameters to the method, right? So it's going and fishing out a value, it's getting another value to the method call saying, based on this value, I don't actually even care. And interpolated string handlers can do that, and the specification for it is kind of gnarly because of that. But again, you don't have to know.
It's really gnarly.
but it does mean, so in this case, it means that actually it does change the semantics of the code a little bit. It really helps the performance, but it also means that the expensive calculation doesn't happen, which, you know, if it had side effects, that will be observable. So we're getting into territory where this is actually making the behavior different as a sort of like, you know, unfortunate but unimportant side effect. But the next one is really about where that is the whole point of the interpolated string handler, is to change the meaning of the interpolated string itself.
Right, and this is an API. This is a new API, right, in .NET 6, the string create method, which takes, again, a default interpolated string handler. And the idea here is that interpolated strings, by default, because they just call toString on a string builder, by default, they're current culture, because when you call toString, it's current culture by default in .NET. And so it's always been kind of a, well, it's kind of awkward if I wanted, what if I want that to be invariant culture? What if this is something that's a machine's going to read and not a person, right? And so we added this API in .NET 6 that allows you now to pass an interpolated string, and it won't be evaluated and created here. String.create will use this interpolated string handler to create the final string using the culture you pass in here. And so this is a kind of a hole in the interpolated string sort of story. It was something that we actually talked about a number of times in the C# language design about when we first did interpolated strings. Was like, well, this is kind of unfortunate, it's a culture problem. We even went back and forth on it, if I recall.
Yeah.
And now we have the ability to create API that solves that problem, which is kind of where it should have been in the first place. We didn't really want the language to know about culture info, right? That's kind of that would be new, and so it's now it's in the libraries where it belongs.
Yeah. So interpolated string handlers.
Yeah.
And
yeah, there's other things about these that are a little more esoteric, like they can actually short circuit and stop evaluating certain holes and things like that. If for example, there's an API in some of the memory of T stuff where it's trying to fill up a buffer, and if there's not enough room in the buffer, it won't continue evaluating the interpolated string. It'll just fill it until it hits the end of the things like that. There's been some very interesting things done with these. One of the key reasons for doing these, one of the big asks that came out of it was, if you recall, Mads, there was a big perf bug with logging library in ASP.NET where somebody had passed to log methods that were only enabled for debug. They were log debug methods, and they were passing interpolated strings. And because the check to see if the logging library, the log level was debug, happened inside log debug, all the interpolated strings got created in order to call the method. And so being able then to add an interpolated string handler to fix that was kind of a key scenario we wanted to go after.
Yeah, and these keep propping up. This was just sort of like a hidden cause of performance problems that, at least now when we realize there are places where you have them, we can put one of these handlers in and prevent it. So, and now they're perfect. Yes, exactly. So I think that takes us to the end of the stuff we brought to show. There were a few more features in C#10, but I think we really got to the juicy ones.
Yeah.
I think, I mean, some of these are really not important for end users. Constant interpolated strings is kind of like in the same vein. We were just talking about that before, Dustin, which is like super simple. But if you have an interpolated string where all of the bits are constant, then the interpolated string expression is also constant. And why does that matter? Well, now you can put it in places where you can only have constants, like
in an obsolete attribute, for example.
Yeah.
Well, I can now make this an interpolated string because in an attribute, I can only use literals and constants here. So if I had a constant somewhere that was, you know, like this or something, I could now put that in an attribute.
Yep.
And this will happen during constant folding in the compiler, and we'll just concatenate these during constant folding and produce the string at the end. And it's great for using them in attributes. And you couldn't use an interpolated string in an attribute at all before because it has to be a constant value. So this is a cool one. Dave is a legend, Ed. I agree. You get all this attention, Dave, just for this one troll. It's beautiful, Annie. Sorry.
So I guess this is a good time to point the questions in the other direction and say, what are other things that you would like to hear about? Do you want us to go into a little bit of what's on the docket for C# 11? Do you want to talk more about the design process, or, you know, what are the things on your mind? Whoever speaks first gets to decide what happens in the last 20 minutes.
What's coming up?
C# 11. Oh, can Visual Studio suggest to turn a class into a record?
I mean, it could. We've talked about, actually more likely though is because turning a class into a record can be an overhaul. One of the things we've talked about though is we should have a refactoring that takes a record and turns it back into a class and generates all the extra bits that we did for that, or as much as it can. So you get it generates the deconstruct method and it generates all that. We've talked about that. It's not clear though that that's useful, or that you make that decision very often yet. So I'm happy to get feedback that that's like something you're bumping into and you've had to do it and it's real painful.
It's actually not quite possible either yet.
Not to get it perfect.
The machinery that we build for width can be expressed in source code. So there are some dirty tricks there. Be nice to clean that up in the future, but we can't actually right now.
Yeah, is that our overloading on return types, I think, or something? Yeah.
It's more to it than that. We have some.
It's more than that. Yeah. There's stuff that we can't do in source though. Yeah.
Yeah, not yet at least. We need to add a new language feature so that we could so you could write the source that we would turn it into.
But C# 11 is the next question though. What's on the docket, as Joe says? And Dennis said the same thing. C# 11. They want to know what's in C# 11. And
why don't you scroll up?
Yeah, we could scroll up and say maybe these things. We're in active design on C# 11, and so some of these things are happening. Some of them are in implementation right now, but it's and it's kind of a because we're in active design, some of it is kind of up for debate yet of what makes it into C# 11. These are the things we kind of have, in progress, and then there's another kind of list where we have things that we would slot into C# 11 if we have the time to do them.
Yeah.
But yeah, C# 11 is I mean, there's a lot of cool stuff in here. I just kind of caveating this discussion because your favorite feature may not make it that we talk about. So just be aware.
So let's play a game, Dustin. Let's take turns picking a feature from this list that we want to say a little about.
Gosh, if only I knew them that well.
Well,
Okay, I'll go. I'm gonna pick this one because it's merged.
Go for it. Yeah.
That one's merged, so you're gonna see this one, unless we back it out, which we could do, but it's merged. And it should be showing up in the preview channel of Visual Studio very shortly. If it's not, I can't remember if we've released preview 3 yet or not of 17.1. But parameter null checking. So this is the feature where we automatically generate argument null exception throws for you that everybody wants. We've had this on the table since C#8, I think.
Yeah.
When we did nullable, and we were like, well, this is a perfect kind of, help, added benefit to nullable. Because even in nullable, when nullable being a compiler time feature where it statically checks to determine whether something may or may not be null, even in that feature, if you don't add a question mark to say a parameter of a method, and so you're saying that this should never be null, but the user can still pass null, right? It can still happen, and so the best practice if you're writing a library is to, that other people are going to use, is to still check for null and throw an exception or return defensively or whatever your strategy is. And so to kind of go along with that potential, we want to add parameter null checking, which is basically the ability to add bang bang, exclamation point after the name, and we'll generate the argument null exception for you. So that's a real nice syntactic sugar. It is also it's surprising it took us this long, but we honestly couldn't decide. There was some back and forth on the syntax and what it should be, and then the library team also had requirements that throwing argument null exception isn't good enough because they have other helpers and things like that. And so this ended up being a little bit more I don't know, of a design problem than I think we thought it was going to be, but yeah, this one's merged. So
It's yeah.
So C# 11.
Yep.
It's in.
Right.
I believe it's in .NET 7 SDK preview builds that are like daily builds out there. I believe you can grab it.
Excellent. Yeah. So definitely, in general, go and play with the builds and use the preview, the Langber preview flag, and these features are going to show up as we get them in.
Yeah. Here's the before and after code of what that looks like.
Yeah.
So something we could do.
That's real nice. Yeah, and I think that we don't generate the throw directly. I think we generate a call to some helper method that the BCL sets. It makes it faster and better and more traceable or stuff like that.
Yep.
It's like
all the things.
Yeah.
Yeah.
Oh, cool.
All right.
Good one. Okay, my turn. Let's talk about, why don't we take the semi-auto properties? This is one of Cyrus.
Okay.
So the idea here is that, in C# you either go all out with auto properties and then we completely generate the behavior for you, or you have to go old school. You have to declare a backing field and all the logic that you want. So even if you want to need just a little check or a little something in your body, then you fall out over the cliff and you have to declare the whole property manually. And this is a feature that lets you sort of hit a middle ground. We're essentially saying that auto properties can have bodies, and what still makes them an auto property is that they still have a generated backing field, and you can refer to that backing field using the keyword field is the current design. So if you look at that first example there, the property constraint, you can see that it's an auto property. Still, the getter is still completely auto implemented, but the setter has a body that does a little extra check and throws an argument null exception in the setting if the value is null. So maybe we could allow bang bang on those. I mean, you wouldn't need to do that, but that's another story. But it assigns it to field, which is a special language keyword that references the generated backing field. So in this way, you don't have to write that backing field. You don't have to accidentally expose it. So it's not just like that extra line of code, but it's also that you expose it to other members. Even if it's private, you expose it to other members, and they might accidentally use that instead of the property. You know, there's various ways that maintenance can get out of sync and so on. Just not having to generate it is, and not having to write both bodies in this case also is really useful. That's what I'll say about that one.
Yeah. And this proposal is actually, you know, I think we're kind of breaking this down a little bit in design. So we might not actually do all of this. We might just do part of it or any of that. But this is one we've been talking about actually pretty recently.
Yeah.
So, and recently enough to decide that we don't like the name that's been used here. We're like, semi-auto properties, I don't like it.
Yeah. I don't think we're good enough at having we don't have like a point in time where we say, okay, these are the features, let's make sure they have good names before we ship. Sometimes they just ship with whatever name somebody proposed them with.
And I think in this case, this is the compiler team is calling them this because they want to be able to distinguish them from normal auto properties that have been there forever. And from our perspective, I think, Mads, in the language design, that it's really, they're just auto properties. It's just that auto properties become more functional. You can do more with them. You can express more.
Yeah.
So
that's another, that was my pick. I think we have time for one or two more.
Do we have any questions before?
Oh, I should probably check.
Yeah.
Let's see. Does .NET 6 require you to mark things as nullable or something? Oh, nullable was always opt-in, and I believe the templates that come with .NET 6 now have nullable reference types on by default. So if you start a new project, nullable is on by default. So we're just nudging you a little more in the direction of use this feature. It's good for you.
Mm-hmm.
Still turn it off. It's just the default has changed. A good question. Yeah, string and string question mark. Yeah, that's just the nullable reference types feature, where the refactoring is saying, hey, mark this as nullable because you are likely to put null in it. That put a question mark on the reference type. Okay. All right. I think that's it for the questions. Otherwise, just come online and ask again. Do you want to pick one, Dustin?
I'm looking at these and I'm trying to figure out one that I would like to pick. You go ahead.
Okay. There's one that I don't actually see on here because I think it's down on the next list because we started working on it in the C# 10 timeframe.
Sorry. There's a lot of lists here.
It's a big one, but I'm not going to go very deep on it, which is the static abstract members in interfaces.
This is a banger, honestly. This is great.
This is a huge feature from several perspectives. It requires runtime support that is non-trivial, for instance. The idea is that we're inching into territory of static members being able to be abstract. So that's never been the case before anywhere in C#, but we're doing it only in interfaces. So an interface can now have, for instance, a method that is static and abstract. And what that means is that an implementing class or struct they have to have an implementation for that static member. Okay. And the way that you then get to call it is in a generic setting, right? So you are, if you have a T that's constrained by that interface, then you can call a static method on the T. Now, why would we want to go do that? What's an interesting scenario for that? The main scenario that we've been pursuing so far is allowing you to do numeric abstraction. So one of the things that you can't do is you can't have a virtual plus operator because operators are static. But what if you could? Like if we allow abstract statics, now you can have an abstract operator plus. So yeah, this is the main example where there's an interface, let's call it iaddable here, that actually abstracts over things that have a plus and a 0. And not only could we have such interfaces and implement them with our own primitive types and leave them for everyone else to implement on their numeric types, but we will. So we have, alongside with this language feature, allowing abstract statics and interfaces, we are also, we've also prototyped the whole library of interfaces that represent different mathematical shapes. And we've implemented them on all our own types. And we've implemented overloads of all the methods in system.math where it makes sense, that are actually generic overloads where the t is constrained by whatever numerics, typically I number of t, that is the appropriate one for that method to be implemented. So it's essentially we've introduced full like abstraction capability for numerics, which is a huge deal in many places. Imagine now implementing a matrix type that can actually have the matrix that can be generic over its element types in the matrix. Like whatever is inside of the matrix is a t, a type parameter t, but that type parameter t is constrained by an interface that lets you do math operations on it, so that even though so that we can write a generic matrix that can do the cross product, for instance, and those mathematical operations that you can do on matrices without knowing its exact element type, just by knowing an interface that they are constrained by. So that's very exciting. It's a big deal. We implemented a prototype of all of it, even in the time frame of C#10, so that we have a good long lead time to get the feature fleshed out completely, to get a lot of feedback on it, and to ensure that we satisfy all the scenarios that are out there, not just our own.
Yeah.
So that's probably the biggest feature slated for C#11.
And there's a blog post out about this, because you can use this today in .NET 6, even though it's C#10. You can play with it. It requires you to to add some project, some GUI to your project to make it show up. But that's in this blog post. There's also another compelling reason for an example of static abstracts in interfaces that is not generic math, which is the idea of like there's also an iParsable of t coming in this .NET 6 preview feature, which means that, say, anything that has a parse and a try-parse static method will implement this interface, and then you can write methods over it. So, for example, that are generic. So I could have, for example, a method called parseAll of t, where t is an iParsable of t, and then I pass to it an IEnumerable of t, and then I could call try parse on every single one and produce a list at the end of all the things that were able to be parsed, and then I could use that with, say, GUID and datetime and or that sort of thing. Right? Well, sorry, I would pass in an IEnumerable of string. Sorry, I said of t, and I could parse those out potentially and produce something, and basically write one method that could generically operate on all of these using static methods. Methods. Actually, kind of a cool example.
It's a great example. It's sort of like a classic conundrum. You think about serialize and deserialize as well. Like serialize is easy. You have the object, and it can have a virtual. You can have a virtual method called serialize that you can call on the thing to serialize. But when you're going the other way, you don't have the thing yet, so you don't have anything to have a virtual method on that you can call, right? So how do you do type-specific behavior on this? Well, you do that with abstract statics.
Right. So you can say you can constrain your t to an I'm deserializable, right, interface that of t, and that has a abstract static deserialize method that knows how to do that for that particular type.
They're all specific examples of factories, really. Where you don't have the object yet. You're about to create it, but you still want the behavior that creates it to be specific to the type of the thing you're creating.
Yeah. So anyways, this is a very cool feature. I think it's one of these things that as we're looking at it right now, it seems it's complicated in the same way that, you know, I remember, because I'm an old man, like when we put lambda expressions in the language and everybody started struggling to try and figure out what we're going to do with these, and now they've kind of become sort of, you know, part of the lingua franca of C#. You write lambda expressions and it makes sense. But at the time, it was a paradigm shift, and it was mind blowing. This is kind of our next mind blower in my opinion. I think this one's going to take it far.
We haven't really tinkered that deeply with the type system in like forever. Adding a new like abstraction mechanism essentially to C# is a big deal. So this is a multi-release kind of effort from our side, but we spent a lot of time on it in the C# 10 timeframe, and we think it's going to be ready for C# 11.
Yeah, it allows you to, as I'm looking at these examples, it lets you write very pointy code too. That code looks like it would actually, like it cut you, right? There's a lot of sharp edges.
One thing we realized here, we should probably wrap up soon, but one thing we realized is most of the scenarios here, you really need, the interface needs to have a type parameter essentially representing the class of struct that is eventually going to implement the interface. Like if you look at one of the, let's see, the add.
Right here, right? You know, you have T, but T has to be an I number of T, right?
Yeah.
It has to be,
yeah.
It has to be generic on the type it's going to be implemented on.
Yeah. If you like go to the interface, if there's a declaration of it.
Well, I mean, there's an interface right here. There's the iParsable one.
Yeah. That you see that it takes a T self, because you don't want the parse method to return iParsable, right? Because then when you get it back, you're like, I have some iParsable. I don't know what it is. Now I have to start like doing type checking on it or something.
Right.
You want to get the actual kind of thing that implemented that interface. And so we find ourselves using this pattern all the time of the interface having a type parameter that is representing the resulting type, like the concrete implementing type. And then when, as you can see with GUID there, when you then implement the interface, you pass yourself, the GUID passes itself as the type argument to iParsable, saying I'm an iParsable that produces GUIDs, and that's how it kind of closes the loop on that.
Right.
Okay. That was 2 hours of a lot of C#. Any last questions or comments or things before we wrap up? Sam is coming on his camera.
Doesn't look like we have any additional questions.
Stayed awake the whole time, Joe. I'm proud of you, man. Proud of you.
First time in a month.
No, well done, guys, and highly appreciate it.
Thank you. It was a great pleasure.
Yes, indeed.
Thank you. I'm going to paste a few links in the chat window, and we'll go over them in just a little bit. And Dustin, if you don't mind, I'm going to take back control.
Please do. And I'm going to change my display back to my full-on ultra-wide.
All right, very good. So thanks again to our presenters. Great to have you guys back, or great to have Mads back, and great to have Dustin for the first time. And looking forward to seeing you for C# 11 in the near future. In the meantime, I posted some links in the chat window, and wanted to go through them so you have an idea of what they're about. So essentially, there's a link to the YouTube channel where today's presentation will be edited and posted. And you can subscribe to the channel to get notifications whenever there's a new video uploaded. In addition, some of the tech events that I'll be going through in just a little bit will be posted on my blog. And you can also subscribe to that to get updates whenever anything is posted. And last but not least, sorry, I jumped that one a little too fast. The feedback eval. The link for that is in the chat window. I ask that you fill out the feedback form. This way we can provide Dustin and Mads some feedback on their presentation. In addition, that form will be used for raffle prizes. We have several prizes courtesy of DevExpress and JetBrains, and we'll be raffling those off using the eval forms. So it's critical that you fill those out. Also wanted to let you know about our special offer for those that may have joined the presentation midstream. You can save 35% at manning.com on a selection of books, and the link is also posted in the chat window for that selection. As far as events, here are some events that are going to be happening. Most of them are virtual, and on February 1st in the greater Cleveland area, we have the Ohio North Database Training User Group, and they're going to be discussing 10 questions that you need to know or need to answer before moving to the cloud. So that should be a beneficial meeting. In addition, on February 9th is the kickoff of the Azure Cleveland group. That group has been in hiatus for a while, and we're going to be picking it up and meeting monthly starting in February. It's going to be held on every second Wednesday of the month. And the topic for February 9th will be DevOps using .NET. And then on February 17th is the GlugNet, or the Great Lakes User Group. Are you, Joe and Steve, are you going to be meeting in person or online for the February meeting?
It will be remote.
Okay, very good. Do we have a topic and speaker yet, or TBA?
I'll ask Dustin after this meeting.
Okay. I wonder who the speaker will be. All right, very good. And then on February 24th is going to be the February meeting of this group. A speaker has not been locked down yet, but definitely working on it. The meeting will take place on the fourth Thursday, and so you can pencil it in that for that evening. Before we wrap it up, always like to ask if there are any job openings. Tech Systems always has job openings listed at techsystems.com. But I also like to ask anyone hiring in their workplace, feel free to jump in verbally or enter it into chat. Going once, twice. No one's hiring? There's got to be someone hiring.
Yeah, my office might be. We just hired a bunch of people out of Columbus Insight Enterprises, insight.com.
Insight.com. Okay, very good. Thank you, Ed. Anyone else? Donald is saying State of Michigan, DTMB as a CEPI. That's a lot of acronyms there. Can you elaborate, Don?
Oh, yeah, it's the TTMV, Agency Services Supporting CEPI. Yeah, we're hiring junior developers and the senior developers.
Okay. Do you have a link for people to reach?
I do not. Right off the top of my head, I'm not at my work computer.
Not a problem.
Yeah, it's
if you get a chance, you can email it to me. I would appreciate it.
Sure will.
Very good. Thank you. Anyone else with hiring?
I believe Calibrity, with Calibrity, they're out of Cincinnati. I believe they have a couple of .NET positions open. I'll put a link in the chat.
Excellent. Appreciate it. Okay. Anyone else? And on the opposite end, anyone looking for work? If so, you can reach out to any of the links that are mentioned in chat, or send me an email, and I get emails from recruiters all the time. I'd be happy to forward you any of the openings. Lastly, my contact information, my email, snasser@nistechnologies.com. You can also find me on Twitter @SamNasser. And the link to my blog again is samnasser.blogspot.com. And I invite you to connect with me on LinkedIn. And so with that, thanks again to Dustin and to Mads, and thank you all for attending, and look forward to seeing you in the February meeting. Good night, everyone.